Finally, we will create the Docker image for the second microservice, Kafka to Elasticsearch, and run everything inside Docker as we did in previous microservice. So let's add the build image goal first to Spring Boot Maven plugin in the pom.xml file to create a Docker image. We specify the group ID as prefix and set the Docker image name, and finally set the version with project version as we did previously. Now let's update the services YAML file and include the Kafka to Elasticsearch Docker Compose definition. Here we edit depends on definitions, which indicates the start order of containers. Let's also add depends on to Twitter to Kafka service, which depends on Kafka and config server, while Kafka to Elasticsearch depends on Twitter to Kafka, config server, Kafka, and Elasticsearch. As I mentioned previously, this depends on only specifies the orders. It doesn't do any real check for the health of any service. So we will still need to write some shell script for the real health checks. Now let's adjust the remote debugger ports to prevent conflicts. As you see, we use Java opts to set remote debugger in the environment section of any service definition in the Docker Compose file. For the Kafka to Elasticsearch, we set the volume for logs and also for a startup shell script where we will check if Kafka topics are ready. Remember that we already added a startup check to Kafka to Elasticsearch programmatically. However, I want to add also a shell script here to show an alternative way of checking initialization logic. We have updated the environment variables also here, as we did in the previous services. Like we set the Kafka broker names as Docker host names, as well as Elastic host name. And also we passed encrypt_key as environment variable to be able to decrypt the secrets at runtime. And of course, we use the same Docker bridge network to allow communication between services, and also with Kafka and Elastic clusters. As you see, we run this image as a root, as was in the Twitter to Kafka service. This is to be able to run the shell script and install and run required programs in the shell, like curl command or kafka-cat command. Great, I will now add the check Kafka topics created shell script where we will run an update and then install kafka-cat utility tool using apt-get install command. Then we will run kafka-cat command to list the topics. kafka-cat -l -b kafka broker 1 9092. Then we will assign the result of kafka-cat command to a variable kafka-cat result, log it using echo command, and then check in a loop that if the Twitter topic is created. We will sleep 2 seconds in each iteration until the Kafka topic is ready. After that, continue with the real launcher to start the microservice, which is again located in the CMB lifecycle directory and called launcher. Then we need to create the Docker image using Maven install command. As we stated in Spring Boot Maven plugin definition, it will be created at install phase. We can actually check if we have the Kafka to Elastic image using the Docker images command, and by using the grep command to search for our image name. It shouldn't be there at first. So let's run Maven install command in Kafka to Elasticsearch folder, and then check again Docker images command. It should now return the image name. Here it says the image is 40 years old. It is a strange bug, but it doesn't cause any trouble to us. Alright, we need one more thing again. We need to make the startup shell script file to be executable by using the change mode +x command. Here using +x, we make this file executable. Finally, we can run everything with a single Docker Compose up command. and then check the logs of Kafka to Elasticsearch. We should be able to see the tweets in the Kafka to Elasticsearch logs. Then let's also check the Postman to see the tweets on Elasticsearch. As you can see, we can search a specific record using an ID on Postman. So I will get an ID from the logs and search here in the Postman using /_search, question mark, and specifying the ID in the Q variable. We will learn more about Elasticsearch queries in the next section. Again, please rerun this application by switching to different implementation of Elastic Client. By using the isRepository configuration variable that we created in previous section, you can simply overwrite it in the services YAML file. Let's finally commit the changes to local Git repository, and we are ready to go to the next section, where we will add a query service to query the Elasticsearch using a microservice instead of querying it directly on Elasticsearch URL. Alright, great job so far everyone. I will see you in the next section.